Hello students, in today's lecture we are going to study the uses of dimensional equations, and in our previous lecture we have studied one use of dimensional equations, and in this lecture we will study the remaining two uses of dimensional equations. So let us study the second use of dimensional equations, that is to check the correctness of an equation. Means if we are given a physical equation, we can examine whether it is correct or not with the use of principle of homogeneity. In this case we apply the principle of homogeneity. Principle of homogeneity, which says that the dimensions of each term on both sides of the equation remains same. The dimensions of each term on both sides of the equation remains same. This is the principle of homogeneity. We apply this principle of homogeneity to check whether the given equation is correct or not. Actually we write the dimensions of the equation first of all in left hand side, and then on the second and then in the right hand side. If the dimension of the equation on left side are equal to the dimension of the equation in the right side, then the equation is right. Let us understand this with the help of an example. Suppose there is a formula t equals to 2 pi into under root L upon g. We have to examine whether this equation is correct, whether this formula is correct or not. To check its correctness, so we apply principle of homogeneity first to check its correctness, which says that the dimensions of each term on both the side of the equation remains same. This means the equation on this side, the dimension of the left side of this equation and dimension on the right side of this equation remains same. Then this equation will be true or correct. If the dimension on the left side of this equation, that is this side of equal sign, and on the right side of this equation are not equal, then this equation must not be correct. Okay, so dimension of left side of equation will be equals to, this is the formula. Actually you will study it after some time. This is the formula for simple pendulum's time period of simple pendulum. This is the time period, this is the length of the thread, and g is the acceleration due to gravity. So this is time, and the dimension of left side of the equation must be the equation will be the dimension of time, and it will be square bracket t, and 2 pi is constant in the right side, and hence it has no dimension, because constant has no dimension. Only L and G have dimensions. So the dimension of the right side, dimension of the right side of equation 2 pi has no dimension, only under root L over G has dimensions, will be the dimension of length L will be square bracket L, and this is G, acceleration due to gravity. Its dimension is L t minus 2. So dimensions of the right side will be under root L over LT minus 2. Dimension of L are only L. dimension of acceleration due to gravity g is lt minus 2. L cancels L, it will becomes 1 over t minus 2 square bracket in under root, or it can be written as t power 2 under root. This power 2 cancels square, so this power 2 cancels square root, so it becomes square bracket t. Hence we can say that the dimension of left side is square bracket t and the dimension of the right side of the equation is square bracket t. From this we can say that equation is correct because the dimension of the left side of the equation is equals to the dimension of the right side of the equation. So dimension of left side of equation is equals to dimension of right side of equation, which is square bracket t. Hence given equation is correct because the dimension of left side of equation is equals to dimension of right side of equation is equals to t. Hence the given equation is correct. If the dimension of left side of equation does not equals to dimension of right side of equation, then the given equation is not correct. This is the use of principle of homogeneity. So we have seen this example to clearly understand the principle of homogeneity. Now we have to study about third use, which is to establish the relation among different physical quantities. So take a screenshot of this. Now we have to study about third use of dimensional equations, that is to establish relation among different physical quantities. To establish relation among different physical quantities, this principle says that if we know that a physical quantity depends on how many other physical quantities, then we can establish relation among these physical quantities. Suppose we know in the question that example that time period of simple pendulum t, time period of simple pendulum t, time period of simple pendulum is t, depends upon the mass of the bob, length of the thread and acceleration due to gravity g. This means simple time period t depends on mass of the bob and length of the thread and acceleration due to gravity g, these three quantities. Then we have to establish a relation among these physical quantities. So t is dependent on mass of the bob and length of the thread and acceleration due to gravity. So we suppose that t depends upon the power of m raised to the power a. Time period t is proportional to the mass of bob length of thread and T is proportional to acceleration due to gravity. T depends upon these three quantities, and we have to establish a relation among these four physical quantities. Suppose mass of the bob is m, length of the thread is l, and acceleration due to gravity is g. We suppose that T depends on the power of a of mass m raised to the power a, l raised to the power b, and g raised to the power c. We have supposed that T depends upon m raised to the power a, l raised to the power b, and g raised to the power c. That is, T depends upon m raised to the power a, l raised to the power b, and g raised to the power c. This implies T is equals to a constant k into m raised to the power a, l raised to the power b, g raised to the power c. Here m is the mass, l is the length, and g is the acceleration due to gravity. So, and t is the time period t. We can write the dimensions on both sides on writing dimensions of both sides. When we write dimensions on both sides of this equation, we get the dimension of time t is square bracket t. K is dimensionless quantity, but we take it here. M is the mass, so its dimension will be m, capital M raised to the power a. L is length, its dimension will be capital L raised to the power b. G is acceleration due to gravity, its dimensions lt minus 2 raised to the power c. K is dimensionless quantity because it is constant, so it has no dimensions. If we multiply here m raised to the power 0 and l raised to the power 0, it would not affect the equation. So m raised to the power 0, l raised to the power 0, t raised to the power 1, because m raised to the power 0, l raised to the power 0 multiplied here, and it would not affect the equation, is equals to k. Here m raised to the power a, l raised to the power b, and here l raised to the power c. So these both these powers will add, so l raised to the power b plus c, l raised to the power b, l raised to the power c. Here these powers add, l raised to the power b plus c, and it will becomes t raised to the power minus 2c. So we can equate the dimensions on both the sides. On equating dimensions both sides. Okay, when we equate dimensions on both sides, here m's dimension is 0 and here m's dimension is a, so a will be 0, here l to the power b plus c, and here l to the power 0, so b plus c will be 0. Here t to the power minus 2c, and here t to the power 1, so minus 2c is equals to 1, implies c is equals to minus 1 by 2. If we put c is equals to minus 1 by 2 into this equation, so we get the value of b. B plus c is equals to 0, implies b, c's value is minus 2 is equals to 0, implies b is equals to 1 by 2. So we have obtained b is equals to 1 by 2 and c is equals to minus 1 by 2. Suppose this equation is question number 1. Put the values of a, b and c, this a, b and c in equation number 1. Put a, b, c values in equation 1. When we put a, b, c values in equation 1, we obtain t is equals to k into m to the power a is 0, l to the power b is 1 by 2, and g to the power c, and c is minus 1 by 2. So it will becomes m to the power 0 becomes 1, it will become k into m to the power 0, it will becomes 1, l to the power half over g to the power half, and it will becomes k into under root l over z, because half means square root. So t equals to k into under root l upon g. Thus we have established a relation among t, l and g, and from here we can say that the time period does not depends upon the mass of the bob m. It only depends upon the length of the thread and acceleration due to gravity. So t equals to k into under root l upon g. Plus t is equals to k into under root l upon g. Thus we have established relation, but by the use of dimensional analysis we cannot find out the value of the constant k. This is the limitations of the dimensional analysis. But from experiment we find out the value of k, and it is 2 pi. So the formula becomes t is equals to 2 pi into under root l upon g. Thus we have established the relation among t, l and g, or in other words we have derived the formula for the time period of a simple pendulum. By the use of this principle to establish a relation among different physical quantities, you can establish the different formulas of the physics with the help of this process. Now we have to see what are the limitations of the dimensional analysis. So take a screenshot of this. Limitations of dimensional analysis. First limitation is, as we seen in the previous example, that the value of the dimensionless constant k is not find out with the help of the dimensional analysis. This means the value of dimensionless constant k cannot be find out with the help of dimensional analysis. This is the first limitation of the dimensional analysis, that the value of the dimensional constant k cannot be find out with the help of dimensional analysis, as seen in the previous example. Second limitation is that if a quantity depends on more than three quantities, more than other three quantities, then the relation cannot be find out between them. If a quantity or physical quantity depends upon other more than 3 physical quantities, then relation then relation among them cannot be find out. This means if a quantity depends on more than other three quantities, then we cannot establish relation between them. If a quantity depends upon other more than 3 physical quantities, then relation among them cannot be find out. Okay. The third is, with the help of dimensional analysis, we cannot analyze an equation which consists terms, trigonometrical terms, cannot analyzed equations containing trigonometrical terms like sin theta, cos theta, etc. Exponential terms like e to the power x, and logarithmic terms like log x. Cannot analyze equation containing trigonometric terms like sin theta, cos theta, exponential terms e to the power x and e to the power x, and logarithmic terms log x. If a equation contains these terms, trigonometrical terms, exponential terms and logarithmic terms, then that equation cannot be analyzed with the help of dimensional analysis. Okay, so these are the limitations of the dimensional equations. First is that the value of the dimensionless constant k cannot be find out with the help of the dimensional analysis. If a quantity depends upon other more than 3 physical quantities, then the relation cannot be find out between them. If a physical quantity depends on more than 3 physical quantities, then we cannot find relation among these physical quantities. Cannot analyze equations which contains trigonometrical terms, exponential terms and logarithmic terms. So these are the limitations of dimensional analysis. We will continue this lecture of series, and subscribe our channel if you like our contents, and we will come back with more interesting topics. Okay then, and thank you.